Two farmers enter the same season believing they are playing the same game. The same crop calendar, the same rainfall forecasts, the same fertilizer recommendations handed down by local tradition and regional averages. On the surface, agriculture still looks like an equal contest between individuals and land. But that perception is outdated. Modern farming is no longer a contest of effort against nature. It is a contest of systems against uncertainty. And in that contest, small farmers and technology-driven agribusinesses are not even competing on the same field. For the small farmer, every season feels personal. The land is not an abstract asset. It is inheritance, identity, and survival fused into one fragile operation. Decisions are made with the awareness that there may not be a second chance. A wrong bet on inputs, a delayed planting window, or an unexpected price swing can collapse the entire year. This constant exposure to downside risk shapes behavior. It favors caution, improvisation, and reliance on experience. Experience becomes the primary decision engine because it is always available, even when capital and information are not. Large agricultural corporations operate under a completely different logic. They do not experience seasons as personal trials. They experience them as statistical events. Individual fields do not matter. Individual outcomes do not matter. What matters is aggregate performance across regions, crops, and time horizons. Failure is not avoided. It is anticipated, modeled, and absorbed. This alone creates a psychological advantage that changes how decisions are made long before planting begins. Planning, at scale, is not reactive. It is predictive. Large operations invest heavily in forecasting models that blend climate probabilities, soil data, historical yield performance, logistics capacity, and commodity market behavior. The goal is not to eliminate uncertainty, which is impossible, but to narrow it enough that outcomes fall within acceptable financial boundaries. When something goes wrong, it is rarely a surprise. It is a deviation from a range that was already expected. Small farmers, by contrast, often plan backward from constraints rather than forward from probabilities. Available cash determines input choices. Existing equipment dictates operational capacity. Market prices are monitored, but rarely hedged in a meaningful way. This is not incompetence. It is structural limitation. Without access to sophisticated financial tools or large datasets, decision-making becomes local and reactive. The season unfolds first, and analysis happens afterward, usually when it is already too late to change the outcome. Technology is often presented as the great equalizer, but in practice it behaves more like an amplifier. When embedded inside a coherent system, it multiplies efficiency, predictability, and scale. When adopted in isolation, it becomes noise. Large agribusinesses do not buy technology to appear modern. They integrate it to enforce discipline. Sensors, satellite imagery, and machine telemetry exist to remove guesswork, not to generate interesting dashboards. Data that does not influence a decision is discarded. Data that does is embedded directly into operational workflows. For small farmers, technology frequently arrives without that surrounding structure. A sensor might be installed, but there is no clear protocol for how its readings change behavior. Software may be purchased, but it competes for attention with urgent, physical tasks. Instead of reducing mental load, these tools can increase it, pushing farmers back toward intuition simply to survive the day. The result is a widening gap where technology strengthens those who already operate systematically and frustrates those who do not. As agriculture integrated into global markets, the margin for error shrank. Input costs rose, price volatility increased, and competition intensified. Large players responded by professionalizing decision-making. Agronomy became analytical, logistics became algorithmic, finance became inseparable from production. Farming transformed into an industrial process governed by probabilities rather than instincts. Small farmers remained exposed to the full force of this transformation without access to its protective mechanisms. This is where failure begins to look like inevitability, even though it is not. The problem is not that small farmers work less or care less. It is that they are asked to operate inside a system that rewards scale, integration, and foresight while being structurally denied those very advantages. Effort no longer compensates for uncertainty. Experience no longer guarantees resilience. The rules changed quietly, and many were never told. As the rules changed, scale stopped being just an advantage and became a filter. Those who could operate within integrated systems survived. Those who could not were slowly pushed to the margins, not by a single catastrophic event, but by cumulative inefficiencies that compounded over time. One slightly worse purchasing price here, one delayed reaction to weather there, one missed opportunity to lock a future contract. Individually, these moments feel survivable. Together, they form a slow erosion that eventually collapses the operation. Large agricultural corporations are built to prevent that erosion from becoming fatal. Their power does not come from perfection, but from redundancy. Multiple suppliers, multiple regions, multiple crop strategies running simultaneously. If drought hits one area, another compensates. If logistics fail in one corridor, an alternative is already contracted. This redundancy is expensive to build, but once established, it transforms volatility from an existential threat into a manageable variable. Small farmers do not have redundancy. They have exposure. One location, one climate pattern, one production window, one primary buyer. When something breaks, there is no buffer. The response is improvisation under pressure. Repairs are delayed, compromises are made, and decisions are driven by urgency rather than optimization. Over time, this reactive posture becomes normal. The operation is no longer managed. It is endured. Data plays a central role in this divergence, not because data itself is powerful, but because of how it changes timing. Large players act earlier. They plant earlier, hedge earlier, adjust inputs earlier, and exit losing positions earlier. This temporal advantage is invisible to outsiders, yet decisive. By the time a small farmer feels a problem in the field or in the market, large operators have often already responded weeks or months before. The outcome then appears predetermined, when in reality it was decided quietly in advance. Markets reward this behavior ruthlessly. Commodity prices do not care about effort or fairness. They respond to volume, consistency, and predictability. Large agricultural companies can guarantee delivery schedules, quality standards, and quantities at scale. This reliability allows them to negotiate better terms, secure long-term contracts, and stabilize cash flow. Small farmers sell into spot markets more often, accepting price volatility as unavoidable. Each sale becomes a gamble instead of a transaction. Financing follows the same logic. Capital flows toward predictability. Large operations present lenders with models, historical performance data, and diversified risk profiles. Credit becomes cheaper, more flexible, and more abundant. Small farmers borrow against land and future hope. Interest rates are higher, terms are tighter, and a single bad season can trigger cascading financial stress. Debt stops being a tool for growth and becomes a weight that limits strategic options. Technology deepens this divide by accelerating feedback loops. In large systems, poor performance is detected quickly and corrected automatically. Variable rate applications adjust inputs in real time. Machinery reports inefficiencies before breakdowns occur. Algorithms flag anomalies that humans might miss until damage is already done. These systems compress the distance between cause and response. For small farmers, that distance remains long. Problems surface late, often when intervention is costly or impossible. The narrative that technology will eventually trickle down and equalize conditions ignores this structural reality. Tools alone do not create advantage. Processes do. Without integration, training, and decision authority, technology becomes decoration. The farmer still wakes up to the same uncertainty, but now with more screens demanding attention. Meanwhile, large operations use the same technologies to reduce cognitive load, not increase it. Decisions become standardized, repeatable, and scalable. This is not a story of villains and victims. It is a story of systems evolving faster than individuals can adapt alone. Agriculture has crossed a threshold where intuition must be supported by analytics, and tradition must coexist with modeling. Those who fail to cross that threshold are not punished immediately. They are slowly priced out, season by season, until exit becomes the only rational choice left. The uncomfortable part is that many small farmers sense this shift but lack a clear path forward. They know working harder is no longer enough, yet the alternative feels abstract and inaccessible. Cooperation sounds ideal but is difficult to organize. Data sounds powerful but difficult to interpret. The result is paralysis disguised as perseverance. Seasons continue, effort continues, but leverage does not increase. And leverage, not labor, is what modern agriculture rewards. At this stage, the divergence between small farmers and large agricultural systems is no longer theoretical. It becomes visible in outcomes, not because one side suddenly improves, but because the other stops being able to keep up with the speed of change. Agriculture begins to resemble other data-intensive industries, where success depends less on physical execution and more on decision architecture. The field becomes an interface, not the center of control. Large agribusinesses invest heavily in designing that architecture. Decision-making is formalized, documented, and continuously refined. What works is standardized. What fails is analyzed and either corrected or removed. This process strips emotion from operations. Sentimentality is replaced with iteration. Fields are no longer managed as unique, sacred spaces, but as comparable units inside a broader system. Performance is benchmarked, ranked, and optimized relentlessly. Small farmers, operating without this architecture, experience the opposite. Each season feels unique because it must be interpreted individually. There is no reference dataset large enough to distinguish signal from noise. Weather feels unpredictable because there is no historical modeling to contextualize anomalies. Market swings feel sudden because there is no forward visibility into demand or supply trends. The farmer remains trapped in the present, reacting rather than anticipating. This temporal disadvantage compounds. Acting later means paying more for inputs, selling at less favorable prices, and missing windows where small adjustments could have produced large effects. Over time, the operation loses elasticity. There is no room to absorb shocks, no flexibility to experiment, and no capital to invest in transformation. Survival becomes the primary objective, and growth becomes a risk rather than a goal. One of the least discussed factors in this dynamic is information asymmetry. Large agricultural companies are embedded in networks that share data vertically and horizontally. Seed companies, input suppliers, logistics firms, insurers, and financial institutions exchange signals continuously. This ecosystem creates a shared situational awareness that no single small farmer can access alone. Decisions are informed not just by what happens in the field, but by what is happening across entire regions and markets simultaneously. Small farmers, by contrast, operate in informational isolation. News travels slowly, often filtered through anecdote rather than analysis. Advice comes from local norms rather than predictive models. By the time a trend becomes obvious at the farm gate, it has often already reshaped pricing and availability upstream. The farmer responds, but the response is always late relative to the system. The emotional cost of this isolation is rarely acknowledged. Constant uncertainty erodes confidence and narrows decision horizons. Risk-taking declines, not because farmers lack ambition, but because failure carries unbearable consequences. Innovation becomes something others do. The small farmer becomes a follower by necessity, adopting changes only after they are proven safe, which is precisely when competitive advantage has already disappeared. Meanwhile, large operations can afford to experiment. Pilot projects, test plots, and controlled failures are built into their strategy. Losses from experimentation are treated as investment, not mistakes. This capacity to learn faster than competitors becomes a decisive edge. Knowledge accumulates internally, protected by scale and capital, while small farmers learn the same lessons too late or not at all. As this gap widens, the narrative shifts. Success is attributed to superior management or technology, while failure is framed as poor execution. This framing obscures the systemic nature of the problem. It suggests that individuals can overcome structural disadvantages through effort alone. In reality, effort without leverage accelerates burnout. The farmer works harder each season, yet falls further behind a moving target. The turning point arrives quietly. A farmer realizes that despite doing everything right by traditional standards, the operation no longer produces sustainable returns. Pride delays the decision, but mathematics eventually forces it. Land is leased or sold. Equipment is liquidated. Another independent operation disappears, not in a dramatic collapse, but in a rational exit that feels like defeat only because the system never offered a fair alternative. At the same time, those who manage to escape this trajectory do so by abandoning the idea of farming as an isolated endeavor. They seek scale through collaboration, data through partnerships, and resilience through diversification. They stop asking how to compete with corporations directly and start asking how to borrow their logic without becoming them. This is the moment where the story can still change. By the time the future of farming becomes visible, it is already late for those who refuse to change how they think. The fields may still look familiar, the machinery may still move across the land, but the logic governing outcomes has shifted permanently. Agriculture no longer rewards those who simply endure uncertainty. It rewards those who design around it. This is the quiet line separating survival from exit. Technology giants in agriculture are not winning because they are bigger. Size alone is useless without coordination. They win because they operate inside architectures that absorb chaos and convert it into manageable signals. Weather becomes probability. Markets become models. Fields become variables. This abstraction is not disrespect for the land. It is the only way to manage complexity at scale. Sentiment does not scale. Systems do. Small farmers who fail are often described as victims of globalization, automation, or unfair competition. That description is incomplete. They are casualties of a transition from intuitive decision-making to systemic decision-making. The tragedy is not that they were incapable of adapting, but that the cost of adaptation was never made explicit until it was already too high. By the time survival required structural change, most were already operating at the edge of exhaustion. Those who survive do not reclaim some romantic version of the past. They do not outwork corporations or outsmart markets through instinct alone. They survive by redefining what it means to be a farmer. The identity shifts from operator to strategist, from producer to risk manager, from isolated decision-maker to node within a larger network. This shift is uncomfortable because it challenges pride, independence, and tradition. But it restores leverage, which is the only currency that matters in modern agriculture. The future will not eliminate small farmers. It will eliminate small thinking. Operations of any size that fail to integrate data, collaboration, and financial logic will continue to disappear quietly, one rational exit at a time. Meanwhile, those who understand systems will expand, not always visibly, but decisively. Control will move away from those who touch the soil most and toward those who understand the flow of information around it. This is not a moral judgment. It is a structural reality. The land does not care who owns it. Markets do not care who needs them to be fair. They respond to predictability, scale, and coordination. Farmers who align with those forces regain agency. Those who resist them remain exposed. In the end, the question is not whether technology giants are destroying agriculture. The question is why their logic works so well in an environment that has become too complex for intuition alone. The answer is uncomfortable but clear. Farming did not become harder. It became systemic. And systems do not reward effort. They reward design.